get started again. Last time we stopped here, right? Um, so we have designed this V-belt. We have designed the gear, we have designed the shaft, we have chosen the bearings, and now we need to choose the casing, our casing. So we have sort of this casing, right? And if we go for any car design, gearbox design of any car, it should be okay. This is standard gearbox for, I think, motorcycle, if I'm not wrong. So we have designed this gear, we have designed this bearing, we have designed the shaft how it should be, and now we need to choose the outer casing. Depending on our situation or our specification, it could be different in shape, in size. If I show you something else, I think this is also for a motorcycle or something else, I'm not sure. So you see, this is outer casing. How thick this wall should be and how the inner thing should be depends. So main thing is actually to design this thing and this, then cover it up. And if I show you a cars one, I wish I had. Here it is. Okay, this is car. In our case, you're designing just one pair of gear. In car, they have like 5 pairs or 6 pairs of gears. And this is input shaft, this is output shaft. So a specific transmission goes in. In our case, probably input shaft and output shaft, same thing. It's just a different orientation, depending on our different requirements. We have different other components. This is, I think, bearing, if I'm not wrong. You see, this is ball, and this is shaft, and this bearing is mounted on this. This shaft is mounted on this bearing. This is also a bearing here and here. You see, this is if we cut it through, I told you it looks like sort of square. And in our case, we have bearing here. So I'm not sure, this might be Toyota or some other cars. This is called spline shaft, the sort of spline in outer part. Okay, so if you can design this system, you can go for the other systems as well pretty easily. So now we design this casing for our case, imaginary transmission system. And what else components are needed? This is cover called bearing cover, and if we remove all these bolts here and then open this outer cover, then we see it look inside, right? And this is how it looks like. Cover removed. Okay, we stuck until here, until casing design. If I show you the standard calculation for casing design, it should be this: the structure and dimension of cast iron gear reducer box body. So you can just follow this 1 to 23. These are like different nuts and bolts and other things, like how thick this case should be and how big these nuts should be to withstand this whole system. And then we go for drafting. For our case, see the drafting for in 2 steps. Now one step is you gotta make a hand drawing, or you could do it in AutoCAD easily and show it to her, but it's better to do it by hand because you'll have practiced both. And for hand drafting, it sort of looks like this is original drawing. Okay, this one. Actually, teacher will give you this paper, this graph paper. First you draw on graph paper so that it's easy to draw because you're the beginner. And then you go for final drawing. You show it to her, and if you have some mistakes, she corrects it, and then you go for other drawing. This is, I think, actually is drawing up last year. Anyway, let me show you how to do it in AutoCAD. So this is standard drawing. If I open this guy, this is actually front view, this is top view, and we have one more thing called right side view. I deleted it from here. And what does it mean actually? If we see it from this side, we see the front view. If we remove this outer cover and see it from top side, we see the top view. And if we see it from this side, it's called left side view. So in our case, we have this top view. Just remember, this is bearing cover, this bearing cover. We have 4 bearings, right? 2 here, 2 here. So this cover is this cover. So they have 6 nuts, 1 2 3 4 5 6. These 6 nuts are these 6 nuts, these, and these are mounted like 60-degree apart from each other. So if you divide 360 degree by 6, so it's 60 degree. Okay, and this guy is actually, we have cut it all the way up to this middle line, this line, and we've removed the upper casing, and we have seen it from top side. That's what it is, this guy. And another thing we have done, we have cut through all these gears as well. So wherever they have material, here we have section line, but we have 2 holes here, right? 1 hole, 2 hole. So in hole there will be no section, because there's no material here, so there will be no section line. And here we have this little thingy where it is in, drawing is, this is actually small gear. From here all the way down to here is the big gear. So these are the sections I was talking about, and these 2 are hole, 1 hole, 2 hole. Okay, so you can see 1 gear here, 1 gear is here, and they are matting somewhere else here. This is actually matting line, and this is top of the small gear, and this is top of the big gear. It should be dotted line. Okay, and so how do you start drawing? So this is D1, this big circle is D2, if you remember from our calculation. Here, D1, D2. So our center distance is A, right? And this center distance is actually from here to here, between those 2 gears. or you also can say from here to here. And I'm trying to explain the other components so that you can remember. This is bearing, this is bearing, this is shaft, input shaft, this is output shaft. This gear is rotating, this gear is rotating as well, so they have a transmission ratio between these two gears, and it reduces the rotation speed according to that transmission ratio. And these bearings are actually to support the shaft. Okay, and this is bearing cover. It starts from here, the whole green thingy. If we go to a 3D picture, it should be this guy. If we cut it from the middle and see it from top, we see something like this. And here there are 3 nuts, right? So there are 3 nuts. 1, 2, 3. If we see it from top, cut it in the middle, we have 3 nuts here. Okay, so these 4 are sort of identical. Only difference is they have a hole in between because the shaft is coming out of it. And these 2 bearings are same. These 2 bearings are same. So in draft we just can draw these 4 bearings, these 2 bearings, and in here we just make cross. That means it's identical. Okay, this is the contact point, and we go all the way down here, and this contact point are in the same line. So from this line we start drawing. We make these 2 center line first here, and then make 1 center line, and then from this center line we make this D1, and then this is A. We take this center line like this, 165 millimeter apart, so you can see it's 165 here from here to here. And then from this center we make this big D2. Okay, so now you're clear about this bearing cover, bearing cover, bearing cover, bearing cover, bearing cover, and these are bearing. You can see it clearly. If I show you a standard bearing design from PPT that teacher was using in class, this is a bearing, and if we go, I was talking about this, and this is ball bearing, and this is tapered bearing, and this is thrust bearing because our shaft, when this shaft is rotating, it sort of fluctuates back and forth, and if it is rotating, its power is coming from this direction, it will sort of push it back towards the other direction. So here this is angular, right? If we push us in that direction, so these 2 guys is supporting the other way. So if it's like radial ball bearing, there is no angle, it works actually less efficiently. That's why you have this steppers and all those angular ball bearing. And this is shaft, and this is mount, normal ball bearing mount. This is thrust bearing, this is steppered, this is a standard bearing. If we go to any other car's engine, you see this is sort of, we have cut it from middle, right? If we cut it from the middle, we see sort of box in 2 sides and 1 ball. If we go to any cars, you see the same thing here, a box and a ball, a box and a ball. This is 1 bearing here, 1 bearing here, another one is here. I'm not sure if you guys can figure out any others. Anyway, okay, so there are 2 kinds of mount for bearing. One is called back to back, one is called face to face. If these are in opposite direction, the angles, this is called back to back. These are like facing towards each other. This is face to face. This is angular ball bearing. They have different angle for 40, some has 15, some has 25. It depends. The other kinds of bearing. Look at this 2D. You don't need this all thing now. Okay, so in our case we have this is the end of gear and this is the end of bearing. So in between gear and bearing we have a smaller gap, and to fill up this gap we use something called sleeve, bearing sleeve. I'm not sure if they have any bearing sleeve here. No, actually this guy is working as bearing sleeve. But in our case we don't have this casing. In our case we have so you can see this is the end of gear, this is the end of bearing. So in between these two parts are actually called sleeve. If we don't have these two parts, it will fluctuate back and forth. So in our design we have this thing actually. It's a ring, and it's also here. In output shaft, Laoshi was saying you don't need in this side because this shaft has sort of structure here, like I showed you in this gear. This structure made out of casing, and here it was made out of shaft to support the gear and bearing. But here we have used it. It's okay. We have used it in one side, not in both sides. Okay, and one more important part is this little guy here. This is rubber ring. So actually this whole system is under this engine oil. These are oil. So this guy rotates. This guy rotates, and engine oil goes here and goes all the way to the other parts. So if we have any clearance here, the engine oil will go out and it will create leakage. So to prevent from leakage of oil, we put this guy here. This is a ring around the shaft, and what it does, it prevents oil to go out, and it's inside this bearing cover. And where it is in real life, inside this bearing cover, or inside this bearing cover. Or if we go here, it's inside here, somewhere else here, because oil might go out of this hole. Okay, and you see there are two lines here, one line, two line. These are clearance, because if there's no clearance between this thingy and this guy, it will get stuck and it will not be able to move. Okay, and these two lines, actually our shaft is really big in real life, so we don't have enough paper space to draw them. So we have cut it here and showed that this shaft is actually big. And okay, this is a key. This is also a key. What key does, it locks your gear. It locks this gear with this shaft so that gear and shaft rotates together. We put the key in. They have a group in gear and in shaft as well. Put the key in and put the gear in. Then it locks together. So this is a key. There are also a key here, but we don't see it here because we have cut this gear until here. We didn't cut it all the way through the other part because we can see the section line until here. So key is somewhere else inside. Or sometimes we don't make the key. We make the small gear with the shaft, but but if you need to change your gear for some other cases, you also need to change your shaft in that case, and that's not economical. Okay, what else are the parts? You see the same rubber thing here as well. Okay, then we go here. This is actually oil checker in a standard gearbox or in another where you put engine oil or mobile. You have something like this to check the oil, how much it has. So you open it up and check the level of oil. If it's too less, you put the oil in. And this nut, actually, we open it and drains out all the oil, like burned out engine oil. And okay, here this is called peephole. What it is this guy here. So what it does, it has a hole inside, and when there more pressure inside and when it rotates really fast, it creates heat. So to release the heat and pressure, this small hole opens automatically. If I show you in the drawing, you see this is a hole. It sort of works like a pressure cooker you have at your home to cook meat. It's the same mechanism here. And in other cases, you just can open this one and put the engine oil in. And these two guys here and here are called lifting hook. In real life, it is these two guys here and on the other side here. So you put the hook in and lift it to take it to some other places. Okay, and this is called a boss, and this is height of boss H. You have in your calculation. If I show it here, from here to here. These two guys are rib. These are used to support the structure. This is the same thing here to make the structure more strong. If we come back here, you see this little guy here, this little guy here, or these four lines. These are actually ribs to support the structure. Okay, one more important thing, this little guy here, what it is, okay, you see this little groove here, this little groove. Actually, when these two gears rotates, this gear will take the oil from bottom and it will hit this upper portion and it will go somewhere else here. So we can collect this oil from the upper portion by this groove, and take it all the way to the bearing, all the way to here. Because in this case, it didn't go to bearing, it just drains out here. But we can make it to the bearing, like in our case. So engine oil hits here, goes to this groove, and from top view, these two lines actually. These two lines. This is a groove. These are grooves. So you see, oil is collected here and goes all the way down to this bearing. It's not going directly through here because this is outer cover, outer race of bearing. There's no hole here. We put it from the side. Okay, and another thing to remember is this guy should not go beyond this line because this is the inner part of bearing, right? So inner part of bearing, this guy and the gear should rotate at the same time. If this is bigger than this line, so it will be stuck with the upper part. Anyway, I have close with that. Okay. So actually the sleeve is stuck with this part here, but it should not go beyond this line. if it goes beyond this line, it's stuck with the ball or it's stuck with the upper portion. But actually ball doesn't move, it rotates in its position, and this guy is stationary. Okay, so this is the real thing we're gonna design. There are 3 pairs of gear here, but in our case we already have 2. And this is opened up. This is actually helical gear, and this is worm gear. Not worm gear, I think it's this is helical gear. And you see these bearings are different. This is thrust bearing. But in our case we have input shaft, output shaft here, but same thing. You can see more complicated depending on your requirements. But if you can design 1 pair of them, you can go for the others. And here actually your bearing sits here, and this is sleeve, bearing sleeve. This is bearing sleeve, and you see it goes inside the gear. So they have like gear is a little bit bigger than shaft here in this part. Where is it mean? Here. You see your shaft ends here, but your gear ends here. So gear is a little bit bigger, the shaft is a little bit smaller here, and this guy actually gets inside, get into this hole, and it locks it. Okay. I think now we're good to go. And here these 5 lines are really crucial because she actually checks a lot about this and people make mistake here. And this 5 line, what does it mean? This is matting line, imaginary center line. It's connecting here, and this is the outer part of gear. Like this is gear teeth, right? The end of gear teeth of small gear. This is end of gear teeth of big gear. But when you draw, we normally draw the driving gear on top and driven gear on bottom, because you have cut it all the way through the middle, right? All the way through the middle. So we have driving gear, driven gear. So driving gear's teeth will be top, driven gear's teeth will be on the bottom. So the outer part of it's called addendum actually in more technical way. So addendum of small gear will be visible, but the addendum, the big gear, I mean driven gear, will be here, right? So it's under, we cannot see it from top side, so it will be invisible line or dotted line, this guy. So this is the thing I was talking about. So this top of the small gear, this top of the big gear, and this is actually bottom of teeth of small gear, and this is bottom of the big gear. And the distance between from the center line to this top and this top is actually your module. Where is it? You see your module here is 2, right? So it should be 2 millimeter. Distance from this center line to the top, from this center line to the other top is your module, 2 millimeter. And this and this is actually, or this and this is actually bottom clearance. So if your this gear goes inside this or crosses this bottom clearance, it's gonna stuck. So how far this distance should be, there is a special calculation for that. You learn in machine principle, but to be brief and easy calculation, and for easy calculation we just divide module by 4. Whatever your module is, you divide by 4 and we get this distance here. So I think I'm almost clear. We can pause this video, and in the next video we can start drawing the whole thing.